Thank you for joining us today. My name is Patrick Moran, and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Arno Kandel is the Chief Technology Officer at H2O.ai. He's the main committer of H2O3 and Driverless AI, and has been designing and implementing high-performance machine learning algorithms since 2012. Now, before I hand it off to Arno, I'd like to go over the following webinar logistics. Please feel free to send us your questions throughout the session via the questions tab in your console, and we'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and the slide deck will be available after the presentation is over. Now, without further ado, I'd like to hand it over.
Thanks, Patrick. Welcome to H2O. Excited today. The team has done some amazing work in the past few months and years, and this really is the culmination of many excellent people hours put together. This team has been working very hard to get this product out, and this is the most excited I've ever been presenting. Driverless AI, as you may know, is a platform to do machine. It's very easy to use. It does automatic feature engineering, which means it creates value out of your data in addition to just the data itself. So it's not just machine learning on your data, but it's creating better data out of your data. And it also allows you to interpret the results of this process. It allows you to treat text, not just plain numbers. It allows you to deploy the full machine learning model in the end, including all the data transformations that were key to getting better accuracy. It can handle time series problems. It can even visualize the data automatically and show you insights. And obviously it is super fast, and it uses NVIDIA GPUs that are optional, but if you have them, it will help you be much faster at getting insights if you especially have TensorFlow or PyTorch or any other GPU accelerated algorithms inside. For example, we have LightGBM and XGBoost and TensorFlow. These are the three that we ship out of the box, but you'll see today with the recipe architecture, we can actually have any other backend, such as PyTorch, CatBoost, MXNet, you name it. So this is very exciting for us, and you'll see why. First of all, there is no end for the applicability of driverless AI, right? It can be done anywhere. It's a platform. It's generic. It's general purpose. It's not meant for just insurance or banking use across all verticals, and it's definitely meant to work across the board. And our customers are telling us that there's often astounded or astonished by the performance of the system compared to their manual efforts. Now, obviously, if you combine domain insights and expertise of these expert data scientists and just scientists in general, people who understand their data into driverless, then you can turbocharge your time to discovery, time to solution, and deployment. So it's really meant to save you time. It's not meant to replace people. It's meant to make them more effective. And it's meant to provide guidance as to how to operate with data. So it's not just saying, let me do it for you, but it's saying, here is how we do it, and here is how you can improve the process, and here is what we don't do because it's wrong. So you can learn from it. So for example, for this Kaggle problem that we like to show because it is such amazing achievement that we got here, is that out of the box it lands on the top 10th place in a Kaggle competition that took 2 months to finish, and hundreds or thousands of teams, here in this case actually 3,000 teams participated for 2 months. And in the end, the winning team had a score of 0.42 log loss, where lower is better. And driverless got to 0.43, which is 10th place. And this is with the push of a button. And it only takes 2 hours for driverless that took these Grandmasters 2 months with lots and lots of thought. And it turned out that the winning solution actually reverse engineered the data and found a time dependency in the data after converting a floating point number to an integer. It was actually a timestamp, and so you had to multiply by 365.25 to get back to the day, and then you would have a order in the data, and from that you can derive some features that would basically tell you if something happens, then you can't undo that. So you know basically about the future in your training data. So it basically was a leak, so to speak, because the data wasn't really independent observations. They were connected over time. And this insight got the winners up. So, but that's not actual real world insights, because the company that hosted this competition knew that already, right? So basically it was a leak that was exploited, and that's how you can beat these automated solutions, because it's some kind of domain insight, even though in this case it's useless because it's not extra insights and you wouldn't have it in production time, because you do not know the future in that case. So it shows you how tricky certain of these data science problems are and how hard it is to compete for the last digit. And often in Kaggle, for example, the fight is not just about data science, but also about leakage exploitation, which often can make a bigger difference actually than the feature engineering itself, especially if you're a Grandmaster already. And we have over a dozen at the company right now of the worldwide 150 or so. So we have a very high density of Kaggle Grandmasters, and they tell us that their basic approaches are so smart that they get up there quickly, but then to win it, you have to do even more, right? It's a lot of work spent on data understanding. And if you want to see how we did driverless and how we built it to get to this point, there is a blog I wrote last December, and I will probably make another version this year after all these exciting updates. But this is a maker's culture. It's a team effort. Everybody contributes significantly to the project. This really is a lot of good pieces coming together, such as the automatic visualization that was designed by Leland Wilkinson, who wrote the Grammar of Graphics, this foundational book behind Tableau and of course ggplot and other visualization products. It automatically shows you what's interesting about the data, such as outliers or correlations or interesting histograms, heat maps, and so on. Then there's machine learning interpretation that is done with the MLI package inside of Driverless AI, which can also explain predictions that come from outside driverless, by the way. It will tell you why a certain prediction was made, and that for every observation. So you can say, I declined your credit because of this and this. And it's not just a rough estimate, but actually there is a concept called Shapley value that will tell you for every feature exactly what is the contribution to the outcome. And with a feature, I mean a column. So you can say age contributed this much, income contributed this much. And especially for regression problems, you can actually add up those numbers identically, and it gives you the final outcome. So for a house price prediction, you can literally see how much effect your 7 bedrooms had to the house price, or your 1 bedroom, right? That's interesting, and that's very interesting work definitely for the field. It's still not done yet, and the Shapley values take sometimes a lot of time to compute, depending on which algorithm they're applied to. For trees, there are faster approximations, so we use those in Driverless AI. But for other models, there has to be a new groundbreaking effort made to make it faster. And we are definitely working on that field. There's more that you can do. You can do partial dependence plot and conditional expectations for every person in every record. You can say, if my age was higher, I would have had this kind of outcome, and so on. And all of this is done on a per record basis and on a global basis, and it compares the original features that the user provided, and it compares also the engineered features by Driverless AI. So it's a holistic view of the model, and it also does debugging, not just interpretation. So it will tell you, for example, in what corner of the space the predictions are not as good, and you can learn about that. Now, in the big picture, Driverless AI has really a lot of strengths, but one of the strongest assets is the feature engineering, which combines these raw features as I mentioned. So for example, if you have here a bunch of numeric columns, that some of them might actually be categorical, and the algorithm will figure out whether they are useful as a categorical or not. So if you only have 17 unique values in your integer or floating point column, they could become categories, right? There's no need to say it's only a numeric feature. And when they become categories, you can group by them, and you can say for everybody in this age group, what's their mean income? And then that becomes a feature. But only if you do all this target encoding, as we call it, properly, then it becomes a valuable attribute for the data set. And you can enrich the data that way, and it can make much better predictions, especially when you do higher order interactions. So you can have multiple columns act together. For example, the number of bedrooms, the number of cars, the zip code, and so on. And when you group them all together and you compute statistics for each group, then those are meaningful features. As long as you do it in a proper cross-validated way where you do not cheat, basically. You cannot ever include yourself in a mean income, let's say. Because if you're a billionaire, you will, of course, bias the estimate for yourself, and then you say, oh yeah, I got it right. But obviously, you shouldn't have counted yourself in the estimate. And then for time series, we have a lag-based recipe that is very powerful because it can make these groups, and then for each group, for example, for every store, every department, it can compute the proper lags, which means it takes the past values from, let's say, a year ago, from 8 months ago, and so on, and it can hence figure out periodicity such as Christmas to Thanksgiving and so on, and it can figure out for every department and every store what is the in the next few weeks. And of course, it blends all of that feature engineering with modeling and parameter tuning. So you could say there's a billion possible choices of feature engineering and a billion possible choices of machine learning parameter tuning. And actually, yes, there are at least a billion, if not more, interactions of our parameter spaces. And how do we know what to do? Well, it's a greedy algorithm. It will use tree-based feedback. So a tree will be built on the data. It will figure out what are the higher order interactions that matter. It will build features based on that. It will use a genetic algorithm. It will use a particle swarm algorithm. It will use a Monte Carlo approach. It basically blends all kinds of heuristics and algorithms to figure out what to do next. And as it evolves over time, it tries thousands of features. So it will do all these weird group bys, and it will actually tell you what it's doing. And it will say this wasn't useful, but this is useful. And then it will do thousands of model parameter choices and keep optimizing until it finds something that cannot be improved anymore within reasonable time. Obviously, you never know whether there's something better or not. And often you'll get to something reasonably good quickly, right? It's the Pareto principle, 80-20. After a little bit of effort, you get 80% of the results. And you can see that in the chart on the bottom right. But after a while, actually, this wins Kaggle or gets to the 10th place if you keep it running a few more hours, right? If you stop it after 5 minutes, it will only be place 500 or so. So sometimes it helps to find a little bit better interactions, and sometimes it doesn't. And the algorithm is smart enough to stop, and it cannot improve anymore. And obviously, it has to make sure that when it thinks it's getting better, it actually is getting better. We call that the overfitting avoidance and the correct estimate of the generalization. So how do you know that the model will work for tomorrow on new unseen data? So you have to keep testing it on unseen data. So the data set that we apply the fitted model to is not always the same. Otherwise, you will start getting into a rat hole deeper and deeper, right? Or a rabbit hole. You have to basically change the data set that you're scoring a little bit every time. And that's done with this reusable holdout method. And so there's a way to make sure that you improve your overall pipeline only in an actual way and not in a pretend way. And this is obviously taking into account all the statistics we know that our advisors know to the company. Trevor Hasty, Robert Tibshirani, Stephen Boyd, they have advised us over the years, and we do not just statistics, we also do deep learning, which is more of a brute force approach, but it definitely works, especially for images and text and audio and video and so on. So when there's text problems, we will do NLP, natural language processing with TensorFlow, for example, or with PyTorch. Or for images, it's very useful with the convolutional neural nets that have really made a breakthrough. But for many other problems that are faced by our customers in banking or insurance or healthcare, it's not always the 10 terabyte of image data. It's often the 2 gigabytes of Excel tables, right? Just hugely large Excel tables with numbers and strings. And for that, neural nets are not necessarily the best solution. Quite often they're actually not good. And that's why we blend them all together and use them as appropriate. Now for time series, I mentioned earlier, we do these lag features, but we also have to make sure we have a gap between training and testing to mimic the time it takes you to go to production, for example. And we also need to know how long you want to make predictions for. So there's a bunch of little features that the product has to make sure that it all works fine. But generally, I would say it's a very mature product now. It's been out for almost 2 years, and we're very proud of all the improvements. For the NLP, the natural language processing part, we have not just statistical methods, but also these TensorFlow deep learning methods, as I mentioned. And they can even do custom embeddings. So you can download your own embeddings. It will tell for every word what is the vector that we should use for that word. And this can be downloaded from the internet. There's gigabyte-sized files that you can download that are the embeddings. That somebody trained maybe at Google, some researcher posts a new world-class embedding, and you can just point to it as a file and use it inside of Driverless AI. And that's all you have to do. And suddenly your NLP problem gets solved even better. Now the roadmap, as you can see here in the box, that's the features that are new in 1.7, and this is the release that's coming out later this week. We've been spending a lot of time on 1.7, but we also have shipped 1.6 long-term support. So 1.6 is the enterprise stable version LTS, just like Ubuntu or other platforms Red Hat. We have a stable version, and now we have 1.7 coming out that has a lot of bleeding edge features that are hopefully stable, but they might need some time to mature, right? So for example, if there's a bug, then we'll make it 1.7.1 and so on. And in a few months from now, it will be the next LTS version. We probably call that 1.8. So what's new is in 1.7 is C++ scoring pipelines, which means we can now score from Python and R with very low latency, not just from Java. We have improved time series recipes. We have a project workspace, and I'll show you screenshots of those in a second. And then obviously the bring your own recipe, that's the center stone of 1.7, and model monitoring. Now the project workspace is a way to make multiple experiments under one umbrella. And you might work on 6 different problems, but this is just the time series problem view if you want. So you make a project for time series, you add a bunch of data sets or maybe just one training and one testing split, and then you run a bunch of experiments, and then you have a leaderboard that you can compare them in. And that leaderboard can also score all these models on new test data, and then you get the score. And you can select the scorer and then compare, for example, different metrics across the board. There's also a way to configure these experiments to more detail than ever. So you have an expert setting control that has tabs now for different sections. So, for example, there's a specific section for NLP, and then you will see only the relevant features there. So this helps people control their experiments. Often you want to just leave the defaults on, but sometimes you might want to be interested in what you can change. Now, R and Python can control driverless AI. So you don't have to click in the GUI, you can actually write scripts. And these scripts can upload data, they can run experiments, they can download the results, they can make predictions remotely, they can pretty much do anything you can do from the GUI, because every call from the GUI goes to a Python backend, and the same calls can also come in via REST APIs from these clients over the internet, right, over the network. So you can be at home on your laptop and run an experiment on AWS in the cloud, for example, or Azure or Google Cloud, or on your VPN network in the office or in your server room, and you don't have to be sitting there directly. So these clients are very useful, and you get even secure connections and logins and so on. Everything that you would want from an enterprise point of view is enabled. So now also with R support for the other half of the world's data science population that prefers R, there is now no excuse not to use driverless AI. Especially now that we have these runtimes for scoring. So imagine you have a model, you're done training it, after 3 hours you download an artifact. That artifact could contain just a little file that's a protobuf wrap serialized model, right? So it's a protobuf specification, which means it's a bunch of bytes in a file, and that file is all you need for the runtime, because the runtime library that we provide can read that protobuf byte blob and then score a new row. So you give it a row and say, here's my age, my income, that's my score to default. And immediately within milliseconds you get the answer. And you get that in R, Java, and Python using nothing but this runtime library and the protobuf state that you get from the model. So no need to have virtual environments in Python, no need to download anything else. This runs in isolation on a small chip somewhere on the edge or on your servers or in the cloud, wherever you want. And we even have provided 2 quick deploy buttons. One is for the Amazon Lambda endpoint, so you can just specify your keys and the region, and you can deploy it right away. So this is going to give you an endpoint on Amazon's cloud that you can then make predictions from. And also a local REST server where you have the model sitting inside of your server that has driverless on it. So that server now also becomes a scoring server where you can point your commands, or your remote asker, whoever is asking, can point to this port on that machine and say, hey, give me please the answer for this question. What's the tweet sentiment for this, hey, have you just given up question, right? And then it will probably say, well, the sentiment sounds a little bit negative here. So this is how it works. It's all very easy to use, and we are working on even more of these scoring endpoints. One would be Thrift, for example. Now with the bring your own recipes, on which I'll focus for the rest of this presentation, you have a way to manipulate a piece of driverless AI, not everything yet. So there's no way, for example, to join 2 tables at the very beginning. We know that people are asking for that. Right now you can import data from a variety of sources, but then you cannot join 2 tables and turn it into a 3rd table and then run an experiment on it. And you know why? Well, because we don't have a way to productionize that same logic, right? Like, how would you do that in production? You would have to join in production as well. So we are basically giving you end-to-end solution for whatever you can do in production right now. And since we don't have that yet, this augmentation for production, it's not yet enabled in the product. We do have prototypes for that, and it's coming out probably by the later fall or winter quarters this year. But that's something that we're working on. Now, assuming you have the data in the right shape, let's say you already did the join yourself and you now have the data in driverless. Then, of course, whatever happens now will work for you in production as well after this is over here. So what happens here? We say, well, visualize it maybe, look at it. If it all makes sense, you say, well, what would I want to run on it? Would I just run with defaults? Yeah, why not? Let me run it with defaults to see how it works. and then we can deploy it, put it on a REST server and run a Shiny or a little app, something to show end users what the outcome would be. Or you can score it, you can compute diagnostics, metrics, and so on, figure out how good the model is. But maybe you want to do more. Maybe you want to really tune the model for the next 5 days. And you're wondering what happens if I have TensorFlow? What happens if I have ARIMA? What happens if I have Profit? What about CapBoost? What about PyTorch, MXNet, SVMs, KNNs? What about unsupervised enrichment? What about embedding of text sentiment mappings? Anything that you want to do, you can now do. And how do you do that? Well, you go into the experiment and you say, add my recipe. And if you don't have a recipe, you can use our recipes. We built about 70 or so, 75 maybe right now. And these recipes serve as templates for you, and you can extend them. If you don't want to code, no biggie, you can just leave it and everything will work just fine. But if you do want to play with it, now this is your chance. And this really is a powerful way of controlling driverless, because your recipe acts just like our recipe, right? There is no difference in whether you wrote it or we wrote it. The same Python code that controls the logic of the data transformation, and it's the same runtime, the same backend that executes it. There is no performance penalty or anything. And these are just some of these examples here. There's a GitHub repository, totally open source, of course, Apache v2. You can get everything here, use it for any purpose you deem fit. All these recipes will run inside of Driverless AI. There are 74 of them. And these are all code snippets that we wrote in the last month or so. And you can definitely take these and run. Now, how will it look like in your experiment? First of all, you have a choice of all these new algorithms suddenly that you imported. One example on the left. So now you have extra trees, CatBoost, KNN, your own versions of our XGBoost or LightGBM algorithms, but the only difference is a new gradient and hashing so that you can make your own custom loss functions in Python if you really want to optimize a very specific problem for your business. You can not only control the model, you can also control the transformers, right? You can compute your own log of a number, or you can string split, or you can convert numbers and categoricals into these groupings, and then compute statistical means in each group and remember those. And then when a new test set comes, you can do a lookup on those, all that kind of stuff. So if you're a Kaggler or somebody who does data science professionally, you know how hard it is to write all these recipes, but how nice it is to actually have a library that works. And when Driverless accepts your recipe, it basically tells you, we know that it will pass our sanity check. So if it is not reproducible, or if it's not making per row transforms, for example, of new test set rows, then it will complain and say, hey, this is not a valid recipe. So we actually help you write better data science code. And once it's accepted and it works on a bunch of experiments, you kind of feel good about it, right? Then you have a new secret recipe that you can reuse over and over again. And it's not just a script in some folder somewhere that you have to then remember in a few months from now that you still have it or not. You can basically have your own curated recipe repository. Whether you share it with the world or not is up to you, right? You can have a local closed source repository. All of these recipes that you put into Driverless stay on your server. They're not going to the cloud or anybody, unless you, of course, have a cloud server which you upload them to. But we don't get your recipe. It's only for you. It's your own proprietary IP, and it stays with you, unless, of course, you want to share logs with us that contain information about the recipes, for example. But by default, it's really up to you to just improve your own experiments. Here you get an example, for example, for the NLP sentiment problem. So we have an airline sentiment Twitter data set where there's one text column and then there's a sentiment that says like low, medium, high, basically. How happy are these people? Are they negative, neutral, or positive? And that's it. You only get a text column and you have to predict the sentiment. Now, if you do the version out of the box on the left, you just click the button and say go, then you get a log loss of 0.6. If you go to the very right here and you say in Driverless, enable some TensorFlow recipe, which you can do by lowering the interpretability or by just leaving it all on default, then actually when TensorFlow kicks in, it boosts the performance to 49 log loss. So it got a lot better. This is on the test set, as you can see maybe. It's a little bit small, but you can see here the test scores are 49. So TensorFlow alone makes it much better. But then once you add this extra sentiment recipe, you get one more feature added that's useful to the algorithm. And this is something that's not in Driverless. That somebody had to add a custom recipe. But you can see it boosted it by 1 point here. And that might be significant for your business, right? And this is a one-page recipe. It's super easy to write that recipe. And I'll show it to you. The recipe itself actually, let me see if I can find it, text sentiment. That's the recipe. That's all you have to write. This bit of text, and then upload it, and then you get your improvement. So I'll show you more about recipes, but just to give you an idea, it's not a lot of work sometimes to have a meaningful improvement. So just to clarify, Driverless doesn't just do TF-IDF features, it also does TensorFlow NLP features, but they have to be enabled, which they will be by default in 1.7. They were not enabled by default in 1.6. And it also might depend on the interpretability setting. So if you want a very interpretable model and there is no TensorFlow model that's more accurate, then it will automatically enable those transformers. So there is a bit of knowledge required to know when these will trigger. And we have a preview that tells you whether or not these transformers are part of the model. But this one here only shows up when you actually have a custom recipe enabled. Now here is a time series comparison. By the way, these comparisons are now part of the project Workspace. So you can compare up to 3 models next to each other, which is very useful. And it's not just these summaries and the variable importances, you also get the charts. For example, ROC curves, precision recall, and so on. You get everything in that comparison. Now what happened here was, this is a time series problem. We have stores and departments, and we want to compute their weekly sales, predict those sales. And for many people, time series means ARIMA. So we have to make an ARIMA baseline. Everybody has been telling us, please make an ARIMA baseline. And we always said, well, no, it's not as good as what we do because we think we are smarter with all these lags and so on. But actually, ARIMA might sometimes outperform our lag-based recipe because it can extrapolate much better. And it's sometimes for nice seasonal patterns, it's the best algorithm. So let's make a baseline. So we have now an ARIMA recipe in this open source repository that you can enable with 1 click. And this is now a prediction made with just that recipe. So there's no other features, anything. You take the raw data, you fit the ARIMA estimator on it. It basically takes the time column and the target and nothing else, and it figures out what's the future. And then when you come to prediction time, that's what you get. And this model has a mean absolute error of $3,000 per store. And the default that we have is 2,000. So in this case, we used we actually beat ARIMA, so it's good to know. Before we would just show just this and say this is what it is, and people would say, well, where is the baseline, right? So now we can do arbitrary baselines, especially if you are familiar with certain baselines that you want, you can just use those. You don't need to believe in our baseline. And we also made a Facebook profit forecasting baseline. And that guy is almost as good as us, right? So it's pretty good. So maybe we can do both together and get an even better model. And that's up to you now to just enable both and say go. So it's very easy. You can also look at those predictions in MLI for these custom models. So for example, here we have our default lag-based recipe that will tell us for this day here on October 19, this day's prediction had these contributing factors. So it's mostly because a year ago it was high sales, so that's why it's high sales again. 53 weeks ago, 51 weeks ago, and so on. And that because it's holiday, it also adds a little bit because people have more time to go to the store. Right? So you can see the contributions adding up to the actual total money amount. And now here for the profit recipe, we don't really see what profit is doing inside because it is a black box to us, right? It's now just a little external thing that says here is the prediction. And that prediction is the total amount of the store sales. And that's what it does. So it's a little bit less useful here, but if you imagine you combine the two, you could at least see how much impact onto the outcome had the profit predictions. So is that a meaningful addition to your recipe overall, or is it not? So you can at least interpret the contributing factors for every time point in the future and the reasons why the numbers are bigger or small, especially when they're not so good. Imagine this line was not matching the reality, then you would ask, why is there something wrong? And then you can debug it. Now imagine you disable all transformers except for the logarithm or the rounding transformer that rounds your numbers by 1 or 2 decimals and nothing else, right? And then suddenly you see the log of education show up at the top. Obviously it's not the right thing to do, but you can now basically hurt yourself and your business if you say, well, Driverless told me that the log of education mattered, right? So you cannot disable everything and just use your crazy idea and say, well, that's the winner. You can't cheat that way, right? You cannot, you can obviously, but you hurt yourself. So you have to be careful to leave some of the good stuff in. You cannot just say, I have only my stuff and it wins by definition because nothing else is left, and then that's how good it is. Now the next step would obviously be to look at the performance. If this model actually beats everything else, then maybe you did win. Then you can say, well, my feature is on the top and I have the best performance. What do you say now? Well, then I would say, well, how big is the data? Is it 10,000 rows with an error bar of 10%, or is it actually significant, right? And is it on the test set or on the validation set, or validate? So now we're talking data science about the overall setup. And that's a much more meaningful place to discuss than to say how deep was your tree, or what's the learning rate for TensorFlow. So once you get to that level of actually debating merit between models, then it's all good again. But you can't just be misled by just looking at this variable importance and saying, hey, I won. That's not how you know that you win, basically. You only win if your model in production is actually better. And for that, you need a little bit more than just this variable importance table. So you can't cheat yourself and your company by just enabling your own stuff. That's just like a little warning here. But in reality, if your transformers or models are not that great, they will just be ignored, right? The system is doing an optimization, and it's going to say, well, I like light GBM more than SVM, but I like the target encoding that's built in more than your rounding transformer. So you don't need to worry that your stuff will suddenly become like dominant by accident. It's only dominant if you disable everything else, which by default is not the case. So you actually have to manually override the system to say, force it to only use my stuff. And that's the only warning I want to say right now. Now, if you care about the details, actually spend a lot of time in the last few weeks and days on documenting everything, and we'll spend a lot more time on it as well. There is a whole architecture diagram, technical architecture, that explains in detail what piece of the data goes where, how is it all connected, how do you write recipes, and they are fully documented templates that tell you every method you need to implement, why, how, what are the arguments, what is expected from you, and so on, if you actually want to do this as a developer. You can also just act as a user and just play around with those recipes. In the end, there is an automatic documentation that's produced when the experiment is done. It will show you statistical plots and tables and leaderboards of all the models involved. So it will probably tell you, hey, light GBM was better than your SVM, and these features here are the most useful ones. And it will also now make partial dependence plots automatically. So it will show you for the most important features, if they change, what is the output, the impact onto the predictions. And once the range becomes crazy, it even warns you and says this is a bit extrapolation magic. It might not actually happen, right? You cannot say my house is worth 10,000 and I have 12 bedrooms and I live in Palo Alto or something. That doesn't work. So there is some domain in which those partial dependence plots work, and we try our best to tell you this is the reasonable range. And that's why there's a histogram at the bottom that actually shows you the actual distribution of values. So the right one, for example, shows you my balance limit, and this is the risk of default. So it's a higher risk of default if you have a low limit, but obviously less than 0 doesn't mean anything because nobody has a negative balance limit, otherwise they'll just get money for free. So the only value that really means something is this guy here, and that's the highest risk if you have a very low balance limit. And once your balance limit gets above a certain threshold, the risk is very low, but it will never go lower because there's nobody here. You cannot even know what would have happened had they had a balance limit of 100 million, right? So that's why this histogram here at the bottom is helpful. It shows you this is where we have data to support our conclusions. So now it's up to you to take a test drive, but before we part ways, I'll show you a quick demo and then we get over to questions. So there's H2O.ai, the website. Everything is there, including documentation, recipes, what are they, how they work, and there is more detail, of course, than you ask us. There's a Slack channel where we can answer your questions. Join the community. We're always there. And let me now do a very quick demo to show you that this is all real. So this is the GitHub repo, by the way. Everything is here. We have full code templates that will tell you for the transformer and model and scorer recipe API, how does this class look like that you need to implement. In effect, all you really need is 2 or 3 methods, right? There's a fit and the fit transform and the transform. And out of those, you only have to implement 2 methods. So the actual recipe looks much easier than these templates. So, for example, I showed you one earlier. Let's go to here, down here in the whole list. You can see it easier in this view. So there's a scorer. If you want to, for example, compute the median error for predictions in the top decile, that's all you need to do. You just compute the quantile of the predictions, and you say if I'm higher than those, that's my subset of rows that I'm interested in, and now I compute the absolute error between actual and predicted, and then I compute the median of that. And obviously you can use NumPy and Pandas and whatever you like to do these calculations. And this is all you need to now make a business problem more meaningful for something like marketing campaigns and so on, where you don't need to send something to everybody. You only care about the top decile. And there's more, right? There's models. For example, if you want to do extra trees from sklearn, all you have to say is, here are my arguments that I want to have by default. Here are some parameter tuning choices. And then this is the fit. So you make a class and you pass X to it, and then you call fit. It's not much work. And then once you have the model, you have to set it to the self state so that it can be serialized. And then later when you come in prediction time, you can load it again and then make predictions. So it's not a complicated process. It's very much like sklearn. And the output of all of this is that when you go into Driverless AI, and you, for example, have a data set here, I'll do a credit card demo just for fun. I want to predict whether I will default next month or not. And now in expert settings, I can say upload recipe. And this can be my local recipe that I have from this repository that I just cloned, let's say. And now I can say, okay, I want to have a new transformer for numeric data. And that should be the, let's say, the round transformer that I mentioned earlier. So now it does an upload, it tests the transformer, it tells me, okay, it's good, it works. And now when I say I don't need any more changes, the round transformer should now show up here in the bottom as one of the transformers that are active. If I say, hey, I don't like all this other stuff, I can go to expert settings under custom recipes and include only certain specific transformers. So I can say uncheck all, and the only thing I want on is the round transformer. Where is it here? My round transformer. Now, the only thing ever running is the round transformer, which might not be great because, as we said earlier, we have education and so on in there that's actually categorical, but it's still an integer because it was given to us as an integer, so it will use it as an integer. And the same is true for models. Instead of the default XGBoost and LightGBMs, I can say, hey, I want something else. I really want H2O models, right? H2O has been making models for years. Why not use those? So I'll take H2O models. And now I can go to the expert settings again and say I only want those, nothing else. So I go to the model selection. And out of all these models here, I can say, nope, I don't want anything but H2O GLM, let's say. And now I should see H2O GLM here and round and nothing else. And if I say go, maybe we can even change the scorer. I can use a custom scorer. Let me show that for fun. Binary scorer. So I need to go to recipes, scorers, classification, binary, and I'll pick something like the false discovery rate I want to minimize for a given threshold. And now I can pick that. False discovery rate here. So I have false discovery rate, H2O GLM, and round. Everything is custom, nothing driverless shipped out of the box, right? All brand new stuff. And now it will run an experiment using only this custom Python code, which of course can call C++ in the backend, or in this case Java, because H2O3 was written in Java. So as long as you have a Python wrapper for it, you can do anything. And now it will just run and run and run, and at the end you'll get your experiment summary, everything, you can deploy it. The whole thing will just work. Now, you don't get the Mojo runtime, what I mentioned earlier. These Mojo runtimes, they will only work if you can make a protobuf state. And we yet have to make a protobuf state for the H2O3 models. So if you bring in your crazy, whatever, PyTorch hand-coded something, then we have to make an adapter for all of PyTorch, basically, and say, just like TensorFlow, it becomes a standard serialized format, and then it will work as a Mojo. But until we have that, it's up to you to basically deploy only the Python version, which means it's going to have a pickle, it's going to have a Python virtual environment and all that, and it will work. So you can deploy your crazy models that are made outside of any Mojo land that we control, but it will only ever run as a Python environment. Basically do a pip install at scoring time and install all the dependencies, just like we do it right now. So when you say I want a recipe, let's say cat boost, you have to say what's the module that you need, the pip install cat boost command. And you can also put the version number here. So you tell us I need to have this pip installed, and then we can run. And the same thing will happen in production, right? So we can deploy anything that you do here, but not everything will have a Mojo runtime for low latency scoring. It will just work as a Python scoring environment. but you will be able to score your data sets on your model. So this is H2O GLM on the rounding features and computing my new loss here called FDR, false discovery rate of 0.75. And I can make this go away. You can see the confusion matrix, precision recall curve, lift gains, Kolmogorov Smirnov, everything just like before, even though everything else is basically custom. All right, I think that should show enough of what we want to do here. Let's look at the questions. Oh, that's a great one. FPGA aware, yes. So definitely, yes. If you can write a Python wrapper, you're done, basically. The same is true for Intel DAL or MKL, any accelerating libraries that you may have for your hardware, or if you have something that works particularly well for your, like a TensorFlow that you compile that has the fused multiply adds in it or something that is better than our base version, that can all be imported because it's just a pip install away. Usage statistics from you. We do not collect data from whatever you do. After GDPR, that is taboo. Driverless is not an open source project itself. No, Driverless AI is closed source. This is a way for us to basically have the open top and bottom. So the algorithms are open source, XGBoost, LightGBM, H2O, all open source. The top is open source, right? The custom recipes are open source, at least the ones that we provide or the community will provide. But the actual engine in the middle, the platform, that's closed source. The Python client is available for Windows, yes, not just Linux. And in theory, we could do everything for Mac and Windows and Linux. So just ask us if you want something. If it's not there already, it will be made available soon, I hope. It's all possible. The slides will be available, yes. Let's see what else we have.
That appears to be it for now, or no? If we have any
There's no unanswered. Okay, perfect. Let me wait a little bit. I'm sure somebody will ask more questions.
Sure.
I tried to cover a lot, so there's good questions like, what can I do, right? What's the reach of our capabilities here? And to be honest, only we will know when we try it, right? Like together as a customer team. We are very close to our customers, and if you say, hey, I really like this, you know, blah, 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 some specific TensorFlow, PyTorch, NLP, statistic package, definitely we will be interested in hearing what it is. Yes, we run in Windows and Mac. The whole thing, Driverless, is Dockerized, so you can run there. Windows has a Ubuntu subsystem Linux, a special like version of Ubuntu on Linux, on Windows. We can run in there as well. So we can even run Driverless on our laptops. It's just a question of why would you do that if you have better hardware, right? I have a server at home with 2 GPUs, and that's definitely better than my laptop. So it's not expensive to buy a 2 GPU server. You could buy a DGX from NVIDIA that's really powerful, has 8 GPUs or 16 GPUs, and that will make a big difference to your outcome and your productivity in your workplace. If you already have a Hadoop cluster with 500 nodes that each have 200 gigs of RAM, perfect, you can run on those too. But it's only single node for now. So every single instance runs on one node. There is no clustering right now, but that's going to come in a later stage. So you will be able, at some later stage, maybe later this year, say, here's 10 nodes, run them all together as one big cluster, and then you can submit jobs to all of them. The module scoring pipeline, yes, cannot be created if you make your own recipe, unless you write the module creation logic in that recipe. So in theory, the module could be made for your recipe, and if it's only the log that you want to compute for a number, for example, that's easily modulable. And actually, I made an example that was the very first example I ever made, was that log transformer that has a module method in it. But as you can see from GitHub, it's not the easiest to write, and we don't provide APIs right now to give you a hand. So you would have to ask us whether we can make a module version out of it. basically it's not easy, right? Because it has to be TensorFlow-like or protobuf-like in the end. It has to become a serialized blob of bytes, and you won't know how our format is, and nobody wants to mess with that kind of stuff anyway. This is super low-level techie stuff. So the best we can do is provide helpers for, say, PyTorch or TensorFlow, that anything you do in PyTorch, anything you do in TensorFlow, will just magically work. And I think that's the best path forward. If you make your own statistical math model, let's say, then that is the only thing that we can't automate. That we would have to like let you write that in some kind of a domain-specific language of building blocks for which we have the module version. And that's a little bit in the gray zone right now, how that's going to be done. Pricing model, you best contact sales for that. So sales at H2O.ai. I'm sure they're thinking about lots of ways to monetize for, you know, as pay as you go, maybe also just yearly licenses per user and so on. You'll figure it out. They will definitely help you with that. Yeah, NIME actually has an integration, I believe, of Driverless AI. So this version will be available in NIME and Alteryx and other places that just call Driverless as a black box if you want. And now you can even upload your recipe via this Python or R API. So you don't have to click anywhere to upload a recipe. You can write a Python script that uploads your recipe, controls which ones are enabled or not, and then runs an experiment. And the whole thing can be one little Python script that you put into these external systems that then call Driverless. So definitely necessary to be productive. Although I have to admit, I like to click around, but that's because I develop stuff. I don't actually have to run reproducible pipelines all the time. But by the way, apropos reproducible, we made an effort to make it much more reproducible than ever. So all of these recipes are tested and scanned to be reproducible, right? So if you run it even on different machines, they will have the same numbers coming out in the end if you set certain reproducibility levels to true. By default, it will be the same result on the same machine if you click the reproducible button. If you want it to be the same to a different machine that has no GPUs, then you have to turn a knob somewhere in the expert settings. And then the result should be the same no matter where you run it. Even if you run it in 10 years from now, because it can be virtualized, it should behave the same as long as it's still an Intel box or still an IBM Power box, which we, by the way, also support. Great, I think we only have 50 seconds left, so one last question. Otherwise, I'll hope that you'll get the version 1.7 when it comes out later this week. We're working very hard, actually, right now, all the time. The team has really worked hard, and this is just the beginning for us as a company. The goal is to make every data scientist happy, and that's probably the hardest goal in the world, but we're trying hard. Let us know if you want any changes, if you like anything or don't like anything. This webcast will be available, of course, in the future. So thanks a lot for your attention, and I hope to hear more from you and be able to share more with you in the future. There is more product coming. Thank you very much.